WASA Distance Education. This is MBF3C, grade 11 college prep math. I'm Pete and I'm your teacher. So we're just getting ready to wrap up Unit 2 here. And so this is our Class 4 of Unit 2. Now remember, there is no class tomorrow, Friday, and we'll be back on Monday starting Unit 3. So you better get the Unit 3 materials ready, get them from the Learning Center. You'll need those straight away. Now, another thing that'll help you with your Unit 3 is a clear ruler. Okay, so a clear plastic ruler, and preferably a 15 centimeter or a 6-inch ruler if possible. Otherwise, just go for the regular 12-inch, 30 centimeter ruler. But just because you'll be drawing a lot of figures in Unit 3, and just having that small ruler is great. If you know a student who's got a geometry set, you can just go in and just borrow their little the short ruler that comes in those. All right. So, but today we're just going to wrap up lesson 10 of Unit 2. What we did yesterday, we were looking at the ins and outs of buying a new car, and kind of the centerpiece of that buying a new car is this deal review. Okay, so if you have the deal review, then you're set, right? You just fill it in, and you don't even have to learn the steps. You just plug in everything as you go through, and if there's a number you have to calculate, it should be obvious where you're at. Now, when you're doing the key questions for this, you can do it any way you want, but what I would suggest you do is get a copy of page 32, an extra copy, maybe get a couple photocopies of it, and just use the deal review form that's right there if you're going to hand in a deal review. Okay, so you don't have to do, if not, just abbreviate everything. If you're going to write them out, just abbreviate them all. As long as I can figure out you're doing the deal review and go along, it'll be fine. Okay, I just don't want you to waste your time writing out this whole table. Okay, so there we are. This is the deal review, and the one thing that we missed, or that we didn't do, was the monthly payment. Okay, now one of the things I want to do, I want to double check that I got everything right, because why am I concerned about that? I'm not sure that we got the right loan terms. All right, let me see here what we were doing. So this was the deal review for Patty. Okay, so Patty, this is page 32 that I'm reading here. What I'm showing on my screen is a separate sheet because I didn't have there's no deal review form that's provided right with the question, so I just made my own. So it says Patty's planning a purchase of a new car with an MSRP, and it gives all that information. She does not have a trade-in, but she has a down payment. 3.99% compound monthly for 5 years. Okay, so 5 years, so I don't know why. Oh, I said 5Y. I can't even read my own handwriting. Okay, so I'd probably take marks off myself for not being able to read my handwriting. So that says 5 year. I looked at that and I said, that's 54, but it's actually 5Y. Man, I must have been really out of it yesterday. So let's, and that's monthly compounding. So let's turn that into month. Excuse me. Let's turn that into months. It's going to be 12 times per year times 5 years, and that's going to be 60 months. So I'm just going to cross that and go 60 months. Okay, now we're good to go. And the last thing to work out is a monthly payment. Now to do that, we're going to have to use our annuity formula for the purchase of a vehicle, and the one that gives us R, which is the regular payment. So let's flip back here and find the formula to use. Okay, the formula, financing a new vehicle. There it is. So it's near the top of page 30. Okay. So I'm going to extend the page a little bit here. It'll scroll up and then I'll scroll it back down. Okay. So what we're going to use is R equals, okay, so PV, that's the present value. That's how much you're financing, times I over, let's see, 1 minus, uh, 1, whoa, say 1 and draw a minus sign. I don't know. 1 plus, this is getting worse and worse. All right, it's all right. It's all right. We got it. Okay, there we go. All right, let's hopefully, yes, it worked. All right, 1 plus I to the power negative n. We got to watch that negative n stuff. Okay, now that's the formula, and I got that from near the top of page 30. And hopefully we have everything we need. So the PV is the amount that we're financing. So let's go find that amount financed right there. I'm gonna square this in bold in green. I'm gonna square it in green. There you go. Amount financed. So that's gonna be $23,505.12. So that is the sum of every bit that, right? It's the cost of the vehicle, it's the taxes, it's the fees, it's everything. All the options that you got put on her little sports car. Um, Son, what did she get? She got some nice stuff on that sports car. Anyway, and but then we remove then the down payment. That's the only thing that doesn't that isn't in the amount financed, because the down payment just comes right off the top. Okay, but even the finance fee is included in that amount financed. Okay, it's just a down payment. And if she had a trade-in, that would also go to, right? A trade-in would be the value of a vehicle, and they give you something for it, but you kind of roll your old rusty car in there, maybe get a couple guys to give it a good push for you because you want them to think it still runs. Coast into the parking lot of the dealership, and they'll give you a couple $1,000 for it. Okay, so your loan term 60 months. Let's see how we can work out the I here. So the I is our interest rate. It's the same way we've been doing it all along. So it's the interest rate yearly divided by the number of compound periods per year. So it's 3.9%. So it's going to be 0.039. Watch that 0 there, and divided by 12. So there's our interest rate. And now our n, we already worked out our n at 60 months, right? It's 12 times 5 is what it is. Okay, that's how we kind of started this lesson with me not being able to read my writing. All right, I think we have everything we need to plug into the formula. So the R is going to tell us how much she's going to have to come up with monthly. Okay, and she's borrowing $23,505 for 5 years, which is a fairly long time. So I'm not expecting those payments to be really super high. But let's see what we get. So the PV is going to be 2350512 times I, which is 0.039 over 12. So we do that. Now that can be multiplied straight across. You multiply, if you want to do that in your calculator, you multiply straight across and then divide by 12. Okay. And if you're not sure why you're allowed to do that, just let me know and I'll actually show it to you. Okay, it has to do with the fractions, how they work. Okay, and then down in the bottom here, whoa, I don't really know. Okay, get back to green here. All right, 1 minus 1 plus 0.039 over 12 to the negative, got to watch that, 60. Okay, so that's our formula. Now, if you were doing this, you're doing this in the key questions. This is what I'm giving you the marks for, right? Getting to this step here, that's where you get your marks for the question, because it demonstrates to me that you know how to do this. The rest of it, where you got to punch it in your calculator, you ask your little sister to do the calculation for you, whatever, that's not really, it's a small portion of the marks, right? Getting the right answer is important, but the big thing that's important is being able to set this up, because we assume that if you did this in your work, right, or if you were doing this at home, you'd probably use a calculator, you'd probably use a spreadsheet, you might use a tool, an online tool. So what's important is understanding where these numbers come from, right, and how to plug them into the formula. Okay, so don't get stressed out about actually running this through your calculator, because there's a lot of numbers to type in here. It is difficult. Okay, so what I'm going to do, I'm going to work out the numerator then. So I'm just going to do 23,505.12 times 0.039, okay, and divided by 12. Okay, so I end up with 76.39164. Okay. And then I'll do the denominator. So, and I'm going to start in the middle here, sort of, yeah, in the middle there, and do it pretty much the way we've done it with the compound interest in early part of the unit. Divided by 12 plus 1, and then take that to the power of negative 60. Negative 60. Okay, and then it's 1 minus. So the way I do it now to get the 1 minus is I just actually multiply this whole thing by negative 1 times negative 1 to make it negative, and then just add 1. Okay, it's just a little sneaky little trick to do it. 0.176905128.6. So if there's a way that you can not have to re-enter that in your calculator, it's probably a good thing. Now the way I do it is I'll actually take this bottom number and divide the top one in, and then I'll find the reciprocal. So basically what I do, if this is A and this is, if this is A and this is B, what I do is I find B over A, and then I take the reciprocal of it, right? Just like that. And it's mathematically the same thing, and it lets me keep this in my calculator, and all I have to do is type that one in. It's not quite as arduous to type in. Now, if I knew how to memory on my calculator worked, I could probably do that, but for me, this is just as fast. And there you go, and voila, I have 43182, so $431.82. Okay, now let's see, we look at the book. Okay, so the book is saying $430.80. I'm just going to call that rounding. Someone probably rounded somewhere along the way. Maybe if you get a slightly different answer, you can check. Oh, maybe I typed something in wrong. Let me double check. 07639. Yeah, 164. No, looks about right. Okay, don't know. So this is per month. Okay, now, as long as you've rounded correctly, again, because of rounding in within the question, that might be, as I said, the book says 430, so it's either a mistake in a book or just the results of rounding, where they only use two digits in their original calculations or something. It happens. So again, as long as your answer is close to what is expected, you're going to get the full marks for it. Okay. So do you think that someone who's been saving up, it looks like she saved up $3,000 to buy this car. What was the name of the person? It's Patty. So Patty saved up about $3,000 to buy this car. So do you think she'll have any trouble coming up with $431 a month, right? And that's really the thing, right? If she can put aside maybe $200 every paycheck for 6 months, right, 8 months to come up with that $3,000, then certainly she can pay the $431. And that's really, it's just going to be like 200 and was about 215, 216 bucks every pay bi-weekly. So that's not bad. Most people can manage that. When it gets difficult is when the payment is, when it's like $600, $700, $800 a month, then it can be pretty tough. because you're actually looking more like a rent there than a car payment. Okay. Now you notice that she didn't have a trade-in, so maybe this is her first car, and this is a good amount for her to pay for that first car. But now, if she keeps this for 5 years, or maybe after 4 years decides to buy a new one, now she has a trade-in, right? And so she'll get a credit for that on her next vehicle. You see, and so that'll reduce her monthly payments by maybe a few dollars. Okay. So that was that support question. I think I think we've done all of those. So the next thing we're going to look at then is purchasing of used vehicles, because that's another way that people buy vehicles, and and they can be a good deal. There are some things to think about them. So let's see. Okay, so this is the just the top of page 33 here. So it says buying a used vehicle, and that's where we're going to start. Okay. Now, a lot of us start with used vehicles, maybe our first vehicle or something like that. And there's things to say about it, right? Now, so there are some advantages and disadvantages. On the purchase side of things, there's quite a few fees and taxes you won't have to pay. So you actually not only save money because the vehicle's cheaper, but there's a lot of stuff you don't have to pay for when you buy a used vehicle. And it makes sense, right? Because the government doesn't want, because there are quite a few fees to pay when you buy a new vehicle. And the government doesn't want to eliminate the secondary, the used car market, so they don't charge a lot of those fees on it. They kind of make it a bit of a bargain for people that want to save some money. Now, and we talked about depreciation, right? Vehicles do depreciate over time, and depreciation is just a calculation. It's based on a % reduction every year. And, I talked briefly about this yesterday, but, if a certain batch of F-150s were known to be really reliable, right, maybe from 5-6 years ago, they will depreciate less than, say, a batch of other Ford 150s. I got to pick on Ford both ways here. There might be a batch from 5 or 6 years ago. They're absolute stinkers. They break down, and the parts were bad, and so then they will depreciate a lot more, right? And we've seen that quite a bit. And some lately it seems cars are getting better with the rust proofing. But when in the 70s, you'd see these brand new trucks with just eaten away by rust. It was really bad. So those cars depreciated to almost nothing within a couple of years. And that has an impact on people that buy them, because, when you're spending enough money to buy a truck, you expect to have a reasonable use out of it. Okay, so doing your research before you buy a used vehicle or even a new vehicle is important. So there's a formula for calculating the resale value. And the V, which is the resale value, is equal to P, which is the original purchase price, MSRP. Okay, a lot of times they don't count options in that P, right? It'll really depend on the price of your vehicle. And then it's 1 minus R, which is the annual depreciation rate, which is a decimal, and then to the power n, which is the age of the car in years. Okay, so the best way to see this is an example. So a car has an MSRP, that is the sticker price, 23. Now, and we go by sticker price because the resale value of a car is tied to its sticker price, not how much you paid for it, right? Because you could have gotten a real killer deal from your uncle, right, who has a car dealership. You could have gotten a really good deal, but that doesn't mean that your car is worth less 2-3 years later than someone who who paid a really high price, right? So it's got to be based on the manufacturer's suggested retail price. So a car has a MSRP of $23,500. Now it depreciates at a rate of 16% a year, which sounds pretty high, and that it is. That's the way it happens. Estimate the resale value of the car after 5 years. Now, remember, it is an estimate, right? Because if you know someone who, let's say they wash their truck every day, even in the wintertime. Let's say that they vacuum it out every morning, okay? And if somebody sits in a car, they immediately dust off the seat after they sat there, right? That car is going to have a higher resale value, even if the depreciation says it would be lower. But someone looks in a car and say, wow, this car is clean, you know? It's perfect, right? And so that's the thing, right? But then you spend a lot of time taking care of your car, and you know, how much is that worth? So 5 years. So we have 23,500 is the purchase price. The R in this case, so the capital R, little r. It should be little r. Little r is 0.16, which is just 16% divided by 10. Now, there's no there there's no compounding period here. It's just a straight up annual depreciation rate, not interest rate, depreciation rate. And then little n, oh, you know what it is? It's autocorrect. The reason those are capitals, happens all the time. You type a little letter, but if it's at the beginning of a sentence, it makes it a capital. All right, so n is, and this is the number of years. Okay, so you just plug everything into the formula. There's the purchase price. There's the depreciation rate, and there's your n, and you crank that through, and so you get 9,827.98. Okay, so that means that if you go to a dealer with that car to trade it in, they probably won't give you the 9,827.98. They'll probably offer you something a little lower than that, but something in that ballpark. And if you wanted to sell that car on, you know, Craigslist or on Sulika Buy and Sell, you would probably want to start around that price, you know, because if you started at 15,000, you know, you'd get all sorts of angry emails asking if you're crazy, right? And then if you start at 5,000, well, then you're giving away some money, right? You're giving away some value if it's in good condition. Okay. All right. So in this example 5. At the bottom of page 33, they're asking a slightly different question. A 3-year-old car is worth that amount. So that's the depreciated value. The next year it's worth that amount. By what percentage is the value of the car depreciated? Wow. You know, that's tricky. But the way they've done it is they've found out the difference between the 2 years. Okay, and then what we're going to do is find out basically percent of a number. If we turn the page here, top of page 34. So what they'll do is they'll take that 3,000 and then they, okay, it's a little strangely worded question, but anyway, so they have the, basically what we're doing here is we're saying what percent is 3,950 of 15,750. That's the question we're answering with this little equation right here. Okay. Now there's lots of ways to do this. Personally, I like to set it up as letting x be the percent, and I'm going to say that x over 100 equals 3,950 over, and then the original number that you're trying to find the percent of, 750. Okay, that's the way I like to set it up, because then it shows me it's a ratio, and all I do is now solve that equation for x. Okay, which if I'm going to run out of room here, but basically x equals 3,950 divided by 5,750 times 100, basically, right? And that's how you do it. Okay, it's exactly the same thing that they're doing in the formula, but I like to set it up this way because it shows you this box here answers this question. You can use that for anything, right? If you know, if someone tells you that they give you $5 off an $11 purchase, right? And you want to know what percent that is, right? 5 over 11 equals x over 100. Solve for x, right? Right. You can do it You can always find what percent a number is that way. Like what percent one number is of another. Okay, so, and then, they came out with 25. It's about 25% depreciation value. Okay, now, oh, look at this. What are two advantages and two disadvantages of buying a used vehicle versus a new vehicle? Now, they're going to ask you this question in a few places, probably in the key questions, possibly on a final exam. Two advantages and two disadvantages of buying a used vehicle. So, what are some of the things we could say about it? Huh? Well, obviously the cost is going to be lower, isn't it? Right? So that's it, and that's an important. Okay, lower cost, lower payments. Okay, you might even say this has sort of been tested, right? Like, it's not going to have any of those new vehicle problems, where the transmission blows up. But within the first month. But I don't even know if that's a good one because it's been tested, but then stuff's starting to wear out, right? So some of the disadvantages, where, where the parts are wearing out. Maybe you buy that new vehicle for $1,000, and then the next month your mechanic tells you, you know what, the transmission in this thing is shot, and the engine is just about finished too, right? So you might be looking at some expensive repairs. Okay. And then what are some other disadvantages? Another disadvantage I would say is lower value. So when you go to trade that car in, let's say you buy a 5-year-old car and you use it for 5 years, you go to trade that in, you're really not going to get much for it, if anything, right? They might even charge you to tow it away. I've had a car like that. They didn't want it as a trade-in at all. Just keep it, get it out of here. And but on the other hand, I got good value out of that car because I used it up until it couldn't go anymore. So, but if you're thinking of a car as an investment and you're the sort of person that trades in your car every few years, then probably a used car is not going to be as advantageous because when you go to trade that in, it's you get less for it. So, all right. So those are some ways to think about it. Now, when you're answering a question like this, I know students sometimes get a little nervous when answering these word type questions, but ask someone, right? Ask your uncle, ask your kukum, what are some advantages of buying a used vehicle? What are advantages of buying a new vehicle, right? Talk to people who've done it and see what they have to say. Um, just write some stuff down. Like I'm not, what I'm looking for is your engagement with the material, not whether I agree with you or not. Okay, because this is an opinion question. So as long as your opinions relate to buying used vehicles, they got to be valid, right? So, so write some stuff down for these word questions. It'll help you, right? And, you'll get some marks for it. All right, so question 5 says, determine the resale value of a 2-year-old car with a manufacturer suggested retail price of $30,450. I wrote over top of that, and an annual depreciation rate of 20%. Okay. Excuse me. So, all right. Well, let's start a new page at the bottom. No, I'll start a new page here. So we're still on page 33 here. No, page 34. But what I'm going to do is okay. So the question is determine the resale value. So this is support. All right. Let's try it again. Okay. Ah. So this is support question 5, SQ5, and that's on page 34. All right. So we're going to use the formula for resale value of vehicles on page 33. And again, in the final exam, you'll get that formula. 1 minus r to the power n. And it says the car's 2 years old, so n is 2. We know that. And the p is 30,450. And the r, the depreciation rate is 20%, which equals 0.2. We could say 0.20. Be careful of that because it's more than 10, so there's no leading zero. It's just 0.20, not 0.20. Right, so we just plug that into our formula. I'll just change that to blue. So the value of the car now after 2 years, is going to be P, which is the original purchase price or sticker price, 1 minus 0.20 to the power n, which is 2, 30,000. Now, if you notice this, what we're basically finding out is 80% of the car's value, aren't we? Over it per year for 2 years. Okay, so 0.8 to the power 2 is 0.64 times 30450. And so there we go. So 19488 is what the current value is. Okay. Okay, it looks like, oh, yeah, okay. So that's how to do those. And let's take a look. Question 5, I think we can probably just determine the monthly payment. Okay, I think I'll leave that for you to try. Okay. Now, the next little bit here is kind of important when you're buying a vehicle of any kind, really. And I overshot this. Let's see here. So this is the middle of page 34. So it says here vehicle costs. There are many costs involved in owning and operating a vehicle. Okay, so it's not just buying a vehicle, making a payment. So it's not just the down payment, right? It's not just a monthly payment. There are other costs. Regular expenses, that's stuff that you're going to encounter like every month or a regular basis. Fuel costs, right? If it costs me a good $30 to go to Dryden and back, at least when fuel is high, because I have an older vehicle, big V8 car, and so I have to factor that in to my trips. I have to make sure that whatever I do in Dryden, I'm going to save enough money or to offset that cost, right? Maintenance costs now, especially my vehicle is getting older now, so I'm encountering more and more maintenance costs, and I'm keeping track of that because there's a point at which it stops making sense to keep repairing stuff, right? So if they tell me I need a part to cost $400, if I plan to keep the car for at least another 6 months, another 8 months, then probably that's okay. But if they tell me I need a part that costs $1,500 and I know I'm going to sell my car in the spring, probably not gonna pay that. Okay. Insurance, just every month you got to pay the insurance and licensing costs. So they send you a sticker or a bill for your license plate sticker. And up here in the north, you can actually decide whether you want it for 1 year or 2, which is a nice thing. But if you pay for the 2-year sticker, well, then you're planning to keep your vehicle for 2 years. In the south, they have every other year, they take your car, they want you to go and get the emissions tested, which just is a way of seeing whether or not it's making pollution. They don't do that up here, but it's something else you have to do down south, and you have to pay for it, and you sometimes have to make an appointment, and it just it's a hassle every other year that you have that we don't have in the north. So the fixed costs. So yeah, and these are things that you could actually predict, and you could make a spreadsheet and budget for them every month. You know what your insurance is going to be. You know every year or every other year what your license will be. You could actually, if you buy the 2-year one, you just divide it by 2, and that's your yearly expense for the license. And then the variable costs, it says the cost the owner has little control over. I wouldn't go that far, because if regular maintenance, you can probably predict things. Gas, how you drive, how much you drive, can kind of predict, how much gas you're going to spend. But repairs, stuff does break down. And regular maintenance, again, it says that the owner has little control over it, but I disagree, because regular maintenance, you're going to bring your truck in, depending on how often you use it, right? If you're driving around through Lookout for 6 months, you probably maybe haven't checked the oil once. If you're driving up and down the winter road like all the time, you probably want to have it checked. Have your suspension checked, have your tires checked. Probably want to make sure the engine's in good condition, because you don't want to be, halfway between here and Sagico and, have it break down. So you do have a bit of control over that stuff, right? If you, when I need to take a forest access road somewhere, I tend to take my wife's little car, so there's less wear and tear on mine. Oh, don't tell her that. Anyway, so but it's just I pick a vehicle that's that I don't mind as much getting a little bit beat up. Okay, so it says rising gas prices. Right now, gas prices are pretty low, but they won't stay low forever. So we do have to consider the cost of gas when we're going places, when we're driving places, when we're planning trips. All right, so let's take a look at the bottom of page 34. I'm going to show you how to calculate fuel consumption, and I just want to point out that it's a two-step calculation. Okay. First, you need to know the fuel consumption rating of the vehicle. Now, in Canada, we use a metric, and the fuel consumption is given in a metric way, 6.2 liters per 100 kilometers. Now, in the old days, it used to be given as miles per gallon, so 13 mpg. That was the old way of doing things. So depending on how old you are, you may be used to doing it this way. So I want to point something out that may not be obvious. The old system, the bigger the number, the better, right? The more miles you got per gallon, right? 13, right? 12, 11, that's like your old 8-cylinder cars like mine. And then, the new ones get 30 miles per gallon. It's great. But under the new system, because it's a number of liters, how much fuel you consume per 100 kilometers, it's actually the lower the number is better. So 6.2, right, is worse than 5, right, which is worse than 2 liters per 100 kilometers. So for the new system, the liters per 100 kilometers is actually the smaller the number, the better, right? And as a matter of fact, once you get an electric car, it will say 0 liters per 100 kilometers, because it's not using any fuel. So just keep that in mind. Now, the reason why it's liters per 100 kilometers, not liters per kilometer, is simply because if we use liters per kilometer, we would end up with very small numbers in the numerator. We'd end up with 0.00, and those are awkward to work with, because if you have a bunch of zeros in a number, it's very common for people to add or remove zeros by accident, and you get all sorts of weird things happening. Okay, so I hope I've explained that, and I think the text, well, we'll see how this version of the text does it, because there's different ways to calculate this. It's a pretty straightforward calculation. Doug estimates that he drives 30,000 kilometers per year, and the average cost of fuel per year is $82 per liter. Now notice that it's dollars per liter. If you said 82 cents per liter, that's perfectly fine too. Notice that the cent sign goes on the other side. It's just a quirk of the way we write money amounts. So watch that, right? What the amount they'll give you is either in dollars per liter or cents per liter, and your answer will be in the same units. It's better when you're working out how much fuel costs to convert everything to dollars per liter. All right, so whoops. So I'm going to have to flip the page here. You can keep flipping back and forth. Okay, so we need to know the fuel consumption rate of the vehicle. Okay, and what we do is two steps. One is we calculate the amount of fuel that he uses in a year. Okay, so he uses this amount of fuel in a year, that many liters. So what it is, it's the number of kilometers of his trip. In this case, it's a year's worth times 6.2 divided by 100. Now, remember that I said earlier that you can just multiply straight across and then divide. And the reason for that is because 30,000 in this case can be written as a number over 1. So basically, when you multiply fractions together, you multiply top and the bottom, and then you can divide through. So in this case, the 30,000 times 6.2, and then you divide that by 100. Okay, and you end up with 1,860 liters. That's how much fuel the person is going to use. That's not the cost of it yet. We haven't gotten there. Now, I'll just in case you're an older person like me, or maybe you studied metric a long time ago in school, I want to point out why we're using big L for liters, because we used to use little L for liters, didn't we? Yeah, years ago we did. That's how the metric system was. It was little L for liters. The reason we use big L is simply that the little L just looks too much like a 1. That's all it is. So at some point, I don't even know when that was. It was a few years ago. The people that decide how these things are going to look said, "All right, we're going to use big L for liters from now on." So that's it. So if you're stuck using little L because that's the way you learn it, perfectly fine. I don't mind at all. As long as I don't mistake it for a 1, then you can use it. Okay. So all these strange things that happen in as things change, right? And you don't read it in the newspaper that, oh, by the way, little L is now big L for liters. So we have this number of liters that he used. Now we need to know how much that's going to cost, right? And the way it works is we have the cost of gasoline per liter. So in this case, it's 0.82, and that's dollars per liter, basically, times 1860 liters. Okay, and so basically, now the liters cancel each other out, and we end up with a money amount. And in this case, it's $1,525.60. So basically, you multiply the total number of liters that he bought over a year times the cost per each liter, and you get the total. So it's two steps: the amount of gas in liters, and then the cost of it. Okay, mistake that students seem to make quite consistently is they'll multiply the cost of gas by the fuel consumption rate, right, and come up with the wrong answer, right? So make sure you do it in two steps. All right, and knowing this number, having a good idea of the number, maybe not really writing down every time you buy gas, but having a good idea of that number will help you budget. Knowing how much gas you use going from Fort Hope to Sioux Lookout or to Pickle Lake or wherever you go, knowing how much gas you use and how much it costs will tell you how much that trip costs, right? And that can be very helpful for your budgeting, right? If you know it costs you $100 in fuel to make that trip, then you better be able to save. If you're able to save $100 on your groceries and load up your truck, then right you're going to come out ahead. Or let's say someone says, "Hey, take me to Thunder Bay with you. I'll pay, right? Your gas. I'll pay some of your gas." You have an idea of how much to charge them and how much to tell them it is. Okay. Okay, so let's take a look at example 2 here. So it says 1 week gas is selling for 89.9 cents per liter. Trey put $25 worth of gas into his car. How many liters of gas did he buy? Round to one decimal place. Okay, well, I'll just quickly go through this. So now what they did here was they took the cents per liter, turned it into dollars per liter, and that's important. Okay, and in this case, it's just a matter of taking the $25, okay, and dividing that by 899, $0.899 per liter, okay, and that gives you an answer in liters. Okay. Let's okay. All right, let's see here if we get some more. No, I think we pretty much. Okay, so let's take a look at question number 3. Example 3. So Christy drives to work every day and estimates that she drives 30,000 kilometers each year. In general, it's recommended to get a lube oil and filter change every 5,000 kilometers or 3 months. Now, ask your dealer, check your manual. Used to be that we got an awful lot of oil changes and lubes and stuff, and nowadays that's less and less. So I know that the dealer here, I brought my car in, 3-4 months, and they say to me, it really doesn't need it. Come back in another 3 months. So, you try to save money wherever you can. So 5,000 kilometers, and it costs $22.95 each time. So that must have been a while ago. It's also recommended to get a brake inspection and tire rotation every 10,000 kilometers. Sure, estimate how much she's going to spend on maintenance this year. Okay, so I think you're given all the information that you need. You're going to say, all right, if it's every 5,000 kilometers, she's driving 30,000 kilometers a year, so she's going to have to get it 6 times a year, right? So that's every other month. That does seem a lot, but that's what it says, so you can work out what the worst case scenario would be. So 6 times, right, in 1 year of the servicing, it's going to be $137.70. Okay, so that's really not bad. And she would just, if she was working out a yearly budget, she would just say, all right, it's $11. Let's call it $12 a month for car maintenance, right? And she would just include that in her budget. Okay, so now she knows. So now, when it comes time for her to get her car serviced, she's not going to look in her wallet and go, oh, I don't have any money, right? Because she budgeted for it. She's ready to deal with that regular expense. Now, the brake inspection should be done every 10,000 kilometers, so she's only going to need that 3 times a year. And she does it 3 times, and it's that amount of money. Now, if she invests that amount of money every year, maybe it'll make her tires last for an extra year or 2, right? And we know tires are expensive, so that's the sort of thing. Maybe her brakes will last longer, right? And so it's important to know that sometimes when we spend this money, it's worth, it's for a good cause. It's not just wasted money. It'll save you money in the end. So there you go. So the sum of those 2 different service amounts per year is this amount of money. So it's $257.67, and if she just divided that by 12, what would that be? It's going to be somewhere close to $20, maybe $22 a month, something like that, for maintenance. And that's how much she'd budget, along with her cable bill and her gas, her regular gas or her bus pass or whatever she needs. Okay. All right. So now, whoops, are we on key questions already? Okay. Now, determine the cost to drive each distance at the given fuel consumption rating. Okay, so we've seen these, and I think we probably, well, let's take a look at that one, that 7A. We'll work that one out. I'm going to make a new page here, support question 7 from page 36. Okay, so after I finish this question, we'll wrap things up. Do remember to get your Unit 3 from the DEC if you don't have it already. You'll need that plastic ruler. See if you can swipe one from a kid that's not using it, a high school student or something. You're looking for a plastic ruler that has a nice edge. A lot of them, if they're being used, they end up having a kind of a rough edge, and it'll draw rough lines. But take whatever you can get. So this is question A. So it's 5,500 kilometers. That's a kind of a okay. All right, 5,500 kilometers. That's and the fuel consumption is 5.6 liters per 100 kilometers. Okay. And the fuel cost is given in dollars. Do watch that. 0.78 per liter. The second part B is given in cents. So you're going to convert the fuel cost from cents to dollars by dividing by 100. So we want to know how much does fuel cost. So the step one is amount of fuel. Okay, I'm going to switch to blue here. We got 4 minutes, plenty of time. So it's 5.6 liters per 100 kilometers times the distance in kilometers. Okay. So all you do here, I think I might have done it the opposite before. Multiply the numbers on the top to 5.6. 5.6 times 50500 equals, and then we get a number, and divide by 100. Okay. Now, you're going to say to me, but what about dividing this fraction first? Perfectly fine. You can do it that way. 5.6 divided by 100 times 50,500. It works out to be the same number. Now, we have to know what that is. That is liters. That's a number in liters. The reason is just, you don't really need to know this, but the kilometers cancel each other out, and the only unit you're left with is liters. That's why that works. Okay, if you take more college prep math, you'll encounter that idea. The units, again. Okay. All right. So then the second part is the cost of the amount. Okay, and that is just basically we have it's 0.78 cents per liter. You could put slash liter, it doesn't matter. Whoa, times 2828 liters. Okay, and again, you'll notice in this one that the liters cancel each other out, and you're left with dollars, which is exactly what you want. You want the cost of the fuel. So 0.78 times 2828, and so it's going to be, whoa, I already had that 220584. So if you're going on a long trip, or 50,000, that's your yearly cost, your bi-yearly cost of fuel. There it is, $2,205.84. Seems a little low. Let me double check with the answers here, and better wrap things up here. Which question was that anyway? 7A. Okay, I don't even lost my place here. 7A, yeah, 2205. Yeah, okay. Just seemed low. It's because the price of fuel is given a really low value. All right, well, that's it for today. We'll start Unit 3 on Monday. Have a great weekend, and thanks for joining us. Bye now.